midterms, we're going to go over the problem solving part. And this is how we're going to do it. So I'm going to expect your participation. And if I'm not satisfied with your participation, I'm going to end the discussion and you can figure out the problem for yourselves. So I'll show you the midterm. Okay. Is my screen clear to everybody?
Yes, miss.
Yes,
It's
miss.
clear.
Yes,
Yes,
miss.
miss.
Okay, so this was your midterms. You carry out the following mix design based on the ACI method. So you are to design a concrete mixture. This is non-air entrained. And you have to use a superplasticizer for the reinforced concrete structure to satisfy the following requirements. So the slump is 150 mm. The design compressive strength is 28 megapascals at days. So you're given the following materials. You have cement, you have your coarse aggregate, fine aggregate, and the super plasticizer. Okay, so before we go through it, I want to show you guys that this the way the blanks are shown to you is actually a clue on how you're going to solve this problem. So you solve the blanks in the order that they are presented. So first step you need to do is determine the estimated water content. So what is it? Anybody?
I believe, miss, it's 0.46, miss.
No.
No.
Estimated water
I'm
content.
sorry, it's the water content.
Again, estimated water content. You'll find it on slide 9. Slide 9, lecture 5. What is our estimated water content?
216, miss.
Okay, estimated water content is 216. Can I get somebody else? So what did you use as the nominal maximum aggregate size? Somebody else.
For the
19.
nominal,
19, miss.
Yes, 19. So given in the problem, you have coarse aggregate, maximum size 25 mm. Your nominal maximum size is one sieve size lower than this. So that's the one where around 90%, I think, particles pass through. So that's 19 mm. Now, if you look at the table, slide 9, lecture 5, you've got 19 mm with the slump 150 mm. You get the estimated water content 216. So the first blank here is 216. Next, estimated air content.
%, miss.
Okay, how did you get 2%?
By using table this nominal size 19 mm and non-air entrained concrete.
Okay, so the problem said non-air entrained. Some of you answered with values from the air entrained, so that is wrong. Clearly stated, here's a problem. This is non-air entrained. So you use the non-air entrained 19 mm. In the table, it's clear 2%. Next, what estimated water to cement ratio is?
.48, miss.
Sorry?
0.48.
If you round up, maybe, yeah. Can I get the exact one? Without rounding.
0.46, miss.
Okay, 0.46. So if you do interpolation, you get 0.4625. But if you wrote 0.46, if you wrote 0.47, I consider it. Even 0.48, I consider it. So how did you get this? Anyone? How did you get this? What given did you use to obtain this 0.46?
Interpolation, miss.
Interpolation sa table, yes, I know, but what values did you use? So I'll need the compressive strength. What did you use?
At 35 and 41, miss.
Okay, let me rephrase my question. What required average compressive strength did you use? Anyone?
28, miss.
No, not 28.
Oh.
Given here compressive strength, that's the design.
36.5, miss.
Okay. So here in the problem, it just mentioned compressive strength. It did not say this is our required average compressive strength for the design mix. Remember that in your notes. Step 1, the required strength there is you need to put in some factor of safety to account for all the variables that are in the mixing. So we don't know who the person who is mixing, we don't know the type of water you're using, so there are impurities and such. These will affect your compressive strength. So if we want to make sure that at the end of the mix you attain this 28 megapascal, so simplified in our lecture we add 8.5, correct? So your compressive strength specified in the problem 28. To get the required average compressive strength that you will use throughout the entire design mix, you plus 8.5, so you get 36.5. Now you use that 36.5 and sakto by interpolation, everything's at the table. Everything is on the table now. Slide 15. By interpolation, you will get 0.4625. Okay, next step. So we got the water to cement ratio. Next step is using the super plasticizer available. Your estimated water content is what? So we have here super plasticizer available. So what now is your estimated water content? Anyone? Hello? Yes, it's said here using the super plasticizer available. The estimated water content is, so yes, obviously, this is the estimated water content when you use the super plasticizer. Klaro naman, di ba? Using the super plasticizer available. So these are the details, super plasticizer. Okay. So how did you get that? How did you get that value? 172.8, how did you get that?
216 minus 10% of 216, miss.
Again? Again?
216 minus the 20% of 216, miss, is
Yes. So
172.8.
that's correct. So in short, that's also 216 multiplied by 0.8. So you get 172.8. Okay, next. The calculated cement content is blank. Okay, as the calculated cement content is? Anybody?
373.6216, miss.
Okay, correct. 373.62. How did you get this value?
The adjusted mixing water over the interpolated, miss, which is 0.4625.
Okay, to get 373.62, that's this 172.8 divided by 0.46. Now, I want to remind everybody that this design mix is a concrete mixture using a super plasticizer. So everything here follows nga we're calculating things with the super plasticizer in mind. So there was somebody who somebody sent something sa chat na 400 something cement content. So I think you guys did that by dividing 216 divide by 0.6, so that's wrong because we're already aware that there's a super plasticizer in this mix. We lowered our water content now. So our new water content is 172.8. Divide by your water to cement ratio. It should be 373.62, not the 400 something. Again, the way the blanks were formatted serves as a hint. What you got from the previous blanks will be used in the next few blanks. So next, after getting your cement content, it says here you need to get estimated super plasticizer dosage. So that is okay. Answer is 3.73. So how did you get this? How did you get this? How did you get 3.73? Hello? Wala.
By multiplying the cement content mixed by the dosage of the superplasticizer.
Okay, so recommended dosage here given. So it's 1 liter per 100 kilogram of cement. So we've got 373 kilograms of cement. So to get this, you just multiply it with this dosage. So you get 3.73 liter per cubic meter. Next, estimated coarse aggregate content in SSD is blank. Okay, first tell me what is the your B bulk the bulk volume of your dry coarse aggregate. Okay, finest modulus is here. Okay, so the bulk volume of your dry rotted coarse aggregate, that's 0.64. How did you get that?
By using the finest modulus and nominal size, miss.
So your finest modulus given 2.6, your nominal size is?
19 mm.
Okay.
Right, yeah.
So 19 mm and 2.6 ng finest modulus. In the table, slide 20, 0.64. Next, what you give me your oven dry estimated coarse aggregate content. Before we get to the SSD, give me the oven dry details here. Okay, how did you get that? How did you get that? 1024 oven dry coarse aggregate content.
By multiplying the uh, BO, BO, B over BO factor miss by the rotted unit weight.
Okay, so you have here 16 times 0.64, you get 1024. Now SSD, answer to here, SSD is? Can I get somebody else to answer? Can I get the value na wala gi round off or anything? Don't round it off, so please use 1024 sa oven dry. Okay, that's 1029.12. That's your answer here. So how did you get this?
By multiplying the CA oven dry mist with 1 plus the absorption capacity over 100.
Okay, so absorption capacity is 0.5%. So 0.5%, convert that, multiply that to your coarse aggregate content nga oven dry, which is the 1024. So that's 1024 times 1.005. You get 1029.12. Okay, next. You need to estimate the fine aggregate content calculated using volume method. So before this, I want someone to give me the volume of the cement. volume of cement? I'll show you the given. Tara. Volume of cement? Hello? Volume of cement? Anybody? Maski sayo, take a guess. Okay, 118.6. How did you get that?
The volume of cement mix is computed by dividing the cement, which is 373.6216 by 3.15, the specific gravity of cement.
Okay, so you get 118. Next, someone give me the volume of the coarse aggregate. Nabali imong numbers. 381.16. How did you get that?
The course aggregate SSD divided by the specific gravity is.
Okay, specific gravity given 2.7. So why didn't we use the coarse aggregate nga oven dry? Why did we use the SSD? Why? Okay, since sand kay SSD ang gipangita. So obviously SSD sa dapat ang i-use sa course. So if you use your oven dry nga course aggregate to compute for the fine aggregate SSD, then the values will be wrong. Next, what other volumes do we need before we can get the fine aggregate content in SSD? So we have the volume of cement. So far, 118.6. We have the volume of your coarse aggregate, 381.16. What else do we need before we can get fine aggregate content? Okay, we need total volume, the volume of water, volume of air, and volume of plasticizer. So you shouldn't forget that the volume of your fine aggregate is whatever total volume of concrete is minus all the other components. So all the other components, that would mean in this case, you've got water, you've got air, you've got cement, you've got coarse aggregate, and you have plasticizer. So your volume water is what? What is the volume of water? The answer is on the screen. 172.8. That's your volume of water. Do not use 216. If you use 216, then you're overestimating your water content because we are already adding in a plasticizer. So volume of water, 172.8. What's the volume of air?
Miss.
Okay, how did you get 20?
2/100 multiplied by 1,000 liters, Miss.
Okay, so that's volume of air, 20. And lastly, what is the volume of superplasticizer? What is the volume of superplasticizer? The answer is on the screen. .73. So why you did not divide anymore by specific gravity? Why I don't need to do that? Yes, the answer is in liters already. We're trying to convert everything to liters. So you have the 1,000 liter, that's the volume of your concrete, minus the volume of cement. We got 118.6, minus the volume of coarse aggregate, that's 381.16, minus volume of water, that's 172.8, not 216. 172.8 minus volume of air, the 2% converted is 20. Then minus the volume of your superplasticizer, also here in liters, 3.73. So what is the volume of your fine aggregate? Volume of fine aggregate, give me the answer in liters. Hello, volume of fine aggregate. 1,000 minus 118 minus 381 minus 3.73 minus 1.172.8 minus 20 equals
303.71 liters.
okay, that's 303. If you don't round off, that's 303.7. So you have now the volume of your fine aggregate, but we need the answer here in kilogram per cubic meter. So that is the answer in kilogram per cubic meter. What do you need to do?
Excuse me, Miss, pila ang specific gravity sa fine aggregates?
Okay, here.
$804.83, Miss.
Okay, so how did you get that?
We just multiply it by the specific gravity, Miss.
So you multiply the volume, ganiha was 303.7, multiply it to 2.65, find aggregate given. So you get 804.81, 82 if 1. Okay, next. Considering the moisture content of your coarse aggregate, so because in the given, our aggregates here have a certain moisture content, we now need to adjust our quantities based on this moisture content. So what is the required coarse aggregate considering the moisture content? Anyone? Coarse aggregate content adjusted? So first, give me na lang what the what's the moisture content that you will use to adjust. Okay, 0.25. How did you get 0.25? How did you get to 0.25? That's in percent. How?
Absorption capacity minus the effective absorption miss.
Okay, so it's given 0.5 minus 0.25. That will give you 0.25%. That's the percentage you'll use to adjust your course aggregate. Now, what's the final answer here? Okay, that's 1026.55. Tell me how you got that.
1029.12 minus 10.29.12 times 0.25 over 100. Yes.
Okay, that's right. So if you look at it, you actually get points for your course aggregate. Even if you got the super plasticizer and the water wrong, you should be able to get your course aggregate content correctly and this one correctly because your course aggregate is not affected by the addition of the super plasticizer. Next, considering moisture content of your fine aggregate. So the adjusted fine aggregate estimate is what? So we have here what do you use? Is your fine aggregate wet or dry? Wet. Okay, so how do we adjust for the moisture content? So you use 3%. How did you get 3%?
Moisture content of fine aggregates minus its absorption capacity, miss.
Okay, so 4.3 minus 1.3, that's 3%. I don't know why, but naagya po yung nasayop, ana. Maraglain ang ihang minus. Sige. Then how did you, what do you do next with the 3%? What to do next with the 3%? How do you adjust the fine aggregate? Okay, that's your 804.8 plus the additional water that you need. So that's the 3% times 804.8. So you get fine aggregate estimate that's 8 to 8.94. Yeah. Okay. Next. So with these two adjusted values, your adjusted water content is now what? Wala? Wala. First, 370.45. How did you get that? So initially we have water 216, right? Then we adjusted it because we're adding a super plasticizer. We now have 172. How did the water more than double this amount? Can somebody else try? Okay, 151.23. How did you get this? How did you get this? Okay, that's 172.8. You add what you subtracted from the course aggregate. So that's plus 1029.12 times 0.25%. Then, since you added to the fine aggregate, you subtract to the water minus 804.8 times 3%. You get 151.23. Okay, any questions? 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 Why was it done this way? Why not another way? So when you got, there are some people, actually maybe most people, when you got to the adjusted mixing water content, they simply ignored the value they got here. They went back to 216. So again, you can't do that because this 216 is the water without the super plasticizer. And we're designing the mix using a super plasticizer. So you have to take into account the water reduction there. So there's an initial water reduction because we're using a super plasticizer. Then the next is because the aggregates have a certain moisture content. Now, why don't we do it like kuan? Nga naman, miss, giuna nato og reduce ang water because sa super plasticizer. Nga wa man ta ni una og adjust sa because of the moisture aggregate, moisture content of the aggregates. Then we reduce the water sa super plasticizer. So you are not, wala. Did that get in your minds or wala? Nganong animan, ngano di man balihon. Kani una, kanina after. Because that's actually what some of you did. Bali siya, giuna og kani, nag-adjust. You went through all the steps without the super plasticizer, then you adjusted. But that's not how it should go. Anyone who wants to take a guess why it's not the way? Okay, that's correct. Sakto nga if when you're getting your sand nga value, if you wait until later to reduce this water content because of your super plasticizer, your sand content, it will definitely change. That's true, but that's not the root cause exactly. So I want to refresh your memory. Ang ato ang mix design, when you get this 216 mo na siya ang required nimo base sa table. Now those table values, they're that way because that's what will help you achieve the strength that you need. So this 216, if it's actually still 216. Okay, wait. Let's take into account na wala yung super plasticizer. For example lang, this problem wala siya super plasticizer. Then once you're adjusting here some moisture content sa water, you're using the 216, correct? You're using the 216. Now let me ask you, ang kanang 216 mo gamay man na or mo dako sa kaning final, the total water inside that concrete, is it not still 216? It's still 216, di ba? It's just that inig-add na to initially sa mix, mas gamay na siya or mas dako because there's initial water sa coarse aggregate and fine aggregate. There's moisture in this which contributes to your mixing water. So at the end of the mix, let's say walay super plasticizer, once you adjust here, if it was 216 at the beginning, it's still 216. If you look at the whole concrete, because there's water from the coarse aggregate, there's water from the fine aggregate, ni gamay man ni or ni dako ni nga value, 216 kaya po na siya. It's just that sa initial, of course, mas gamay or mas dako because there's water in the mix already. Am I understood? Are we on the same page? Now, what happens if you did that first before ka reduce tungod na super plasticizer? Then you're not gonna be able to reduce the water based on the super plasticizer dosage. Okay, let's say 216 imong giuse, then this mix has a super plasticizer. You didn't reduce it first here. Instead, what you did is you did the whole 9 steps the way we usually do it. Then at the end here, once you get this mixing water, then you reduced it with the super plasticizer. It's no longer correct. Because with the super plasticizer, the water shouldn't be 216. It should be just 172. So this 172, when it became 151 here, do you think this mix does not still have 172? It actually still does. So it's just 151 nga water that you're adding at the beginning of the mix. But when you look at the concrete mix as a whole, this is still 172, the total water in there, because of the water from the coarse aggregate and the water from the fine aggregate. Am I understood?
Yes, miss.
Okay. So muna siya, ang kaning 172, we do this first before we adjust due to moisture content. Because actually this adjustment is, we already have all our values. We have everything we need now. This is what we are supposed to use now for the mix. This 1029, 804, 172, 373. Those are the values you're supposed to use now for the mix, if not for the moisture content in your aggregate. But naaman, mo na nag-adjust mo. But mas pag i-adjust na ninyo, when you add it up all together again at the end of the mix, you still have these amounts. Your water is still 172. It doesn't change. It's just 151 at the beginning, but it's still 172 at the end. Got it? Okay. No other questions? Questions? Nga no ginana man. Wala inana nga question. Okay, wala na ha. So after this, you need to get the 10-liter trial batch. So very straightforward. You already have all the answers up here. How do you get the 10-liter trial batch? Anyone? Nobody? Last call, wala? Okay, wala ha? You guys figure that out yourselves. I will discuss now your design project. Okay. So for this design project, you're going to write a paper on the effects of different compressive strengths and also the effects of adding admixtures to the proportions of your cement, water, and aggregate. Aggregate is your coarse and fine aggregate. So that's your gravel and sand. So your paper should show the concrete mix design computations. This is based on ACI 211. This is how we discussed it. And you have to use the absolute volume method when computing for your fine aggregate. Now I've given you the following materials. So I have here cement, your coarse aggregate, the details, and also the fine aggregate. So you have to develop various concrete mixes with the following variables. So there are varying compressive strength. So this is now the required average compressive strength. Take note, no need to add anymore. That's 21, 28, 35, 41. You have air entrained versus non-air entrained. Then you have with superplasticizer versus without superplasticizer. So if you take into account all these variables, you actually will end up with 16 different concrete mixes. So with those 16 different concrete mixes, you're going to use graphs or tables to illustrate the results on how these varying compressive strengths and also the addition of air and superplasticizer. So these are mga chemical admixtures. So how the addition of these chemical admixtures will affect the different proportions of your cement, water, coarse, and fine aggregate. So you use your graphs and tables to illustrate those results. So I need you to comment on those results and discuss the different implications on our environment, the cost per cubic meter of concrete, and the appropriate applications for the different concrete mixes produced. So you've produced 16 different concrete mixes. You must determine where they can be appropriately applied. So your final paper should be at least 5 pages. This is not handwritten. Write this like a mini thesis. So follow the correct formatting. Don't give me a paper with giant font sizes just to reach the 5 pages. I will not accept that. So this is like a mini thesis basically. So all your concrete mix design computations must be included as an annex. So this is not counted to the 5 pages that is required of you. So the 5 pages will be dedicated to your results, the graphs and the tables that you can obtain, then your comments on your results. So that will be your 5 pages. I'm sure murag kulang pa gani ang 5 pages. But I will just require 5. Then you add all the 16 concrete mix design computations. So these are proper solutions. Show your solutions properly at the end of the 5-page report. So you can work individually or in pairs. So up to you. If you want to work individually, it's fine. You submit it by yourself. If you want to work in pairs, only one of you should submit it. I want a front cover of on your report. So really like a mini thesis. There's a front page of the book, right? So you'll have your names on the front cover, and I want you to upload this on Canvas in PDF format. So the file name should contain your surname. So if you're working individually, I expect only one name there. If you're working in pairs, please have the two names as the file name. So do not plagiarize, and you will be graded on content accuracy of your calculation. So this is on sa annex. And organization and presentation of your report deadline is December 2. So I gave this, I think, end of October. So if you guys started it last week, then you've got about a month, which is more than enough. And so if you submit late, I will deduct points. Any questions? Any questions? No questions? Unsa nga slump gamiton? So there are 16 different design mixes. So I expect you to choose an appropriate slump, but make sure that for the 16 different concrete mixes, you do not change the slump. Otherwise, you're introducing another variable into the study. Then, ang pwede nga value sa superplex decider kay value sa midterms, no, don't use that. People sell this superplasticizer in the market. So you can check out Sika. Sika, I know, is popular for mahalon na siyang brand. So you check out their manufacturer's details, and they will give you the dosage of superplasticizer, which you should specify in your report. There are others naman. There's Dovco. There are many people selling this in the market. So you just choose one, show the manufacturer specifications, include that in your report, and of course, tell me what the specifications of your superplasticizer is. Is it okay to work with 3 members? No. Work in pairs or individually? Any other questions? Is this purely calculation and material canvassing, or do we also have to mix this in real life? What do you mean? What do you mean? You comment, basically this is calculation because you're making 16 different mixes. This is also material canvassing because you're going to have to find a superplasticizer. And I guess you mix it in real life, you determine a cost naman, di ba? You comment on your results. There is a certain cost implication for the resulting mix, and there is a certain implication also on the environment. So yeah, mix with real life, maybe a little bit. And there's application naman for the different mixes produced. Any other question? Ang computation kay sample ra or tanan jud, even though same ra ang process. Tanan jud, tanan lang. Unless you want to submit to me an Excel file, I will also accept Excel file for the computations. But you'll have to attach a printout version sa annex as well as your Excel file. You mean we will make a prototype? No, there is no prototype. I don't expect you to actually mix this concrete. I just want you to design it and compute it. Again, do not mix this concrete. Do not submit actual concrete, huh? That's not the that's not our class. That's not the goal here. I'm sure that's the goal sa inyong lab, but this is lecture. So you just need to design it and compute it and discuss your results. If you do the Excel solution, yes, you still have to show me the equations that you used. You can't just randomly put numbers there that I don't know where the numbers come from. So several of you actually did that in the exam. If I don't know where the numbers come from, I don't credit it with points. Any other question? If no more questions, design report, you guys can go. If na may questions sa midterm, you can stay behind. Okay, how do you get the value for the super plasticizer? Again, there are people selling this in the market. So si Sika is selling. I know there are other brands there. I think Davco is also one of them. So you can, it's easy to get this. It's readily available. You Google Sika and their super plasticizer, you can get a manufacturer's specification. Just via Google, it's very easy. It's not that difficult. So you get the values for the super plasticizer there. Manufacturer specs naman na. Whatever I give you sa exam, those mga, what their water reducing capacity is and what the dosage is, those are specified by the manufacturer of the super plasticizer. Just Google it is the easiest way. About sa midterm, if naa sa blue book, ang answer ni wala sa test paper, I actually checked it. I checked both. I checked both your test paper and your blue book. Okay, wala na questions. If wala na questions, you guys can go. Katong naapay question, you can stay behind. You can ask. Wait, turn on your mic lang. Sa katong ni ask, if wala sa blue book or test paper, wala deduction. If it's somewhere there in whatever you submitted to me, I put points. Will you be able to retrieve your midterm papers? Yes, I will return them to the department. You can claim it there. I'll let you know when I'll be able to drop it off. Do I have any suggestions for canvassing the aggregates? For the design report, you don't need to. The details specs for your aggregates are actually given. So your cement, specific gravity is there. Your aggregates are right there. including their absorption capacity and effective absorption. It's all there. You don't need to canvas aggregates. The slump to be used, again, you are to choose an appropriate slump. There are 16 different design mixes. If you've chosen a certain slump, make sure to keep it constant for the 16 mixes so as not to introduce another variable in your study. So slump is up to you, really. Yes, the class is online. If you help, you can schedule consultation. The paper is actually not limited to 5 pages. It just said at least 5 pages. Any other questions? For those who did not pass the midterm exam, will they still be able to pass the subject? That's up to you. I only record numbers. Everything else is yours. Okay. So about the pricing per cubic meter for the concrete, yeah, I guess you can find SRP. It doesn't vary that greatly. If mo change man ang mga cost, it's only because sa distance. So project specific siguro. Which you can specify naman in your report. Okay, for those mo like questions, please leave na. Katong mga naa pa, please turn on your mics. Will I give a short discussion about the essay? So all the answers to the essay are in your lecture notes. If they're not in the lecture notes, they were in the lecture discussion. So if you're listening to the lectures, then yes, you'll be able to answer the essay, and I will no longer give a discussion for that. So medyo spoon-fed na kayo if I still answer those essay questions for you guys. But if you have specific questions for me, then I'd be happy to answer. Okay, if wala na questions, I'll close the room 5:30. Those with questions, you can stay. For consultation, yeah, contact through email, schedule through email. Consultation time varies, so you can just schedule with me through email. If you want a consultation, I'll give you a time.
Oh, hello, miss. Can I ask about the syllabus, miss?
Yeah?
I read mga in your syllabus, miss, na you need to pass the both the midterm and final exam to pass the subject. Is that true, miss?
Kung deserving naman, dili man ko manghagbong.
Oh, okay, miss. Thank you, miss.
Thank you, miss.